Citizens, back with me again, Aji Gautama Putrada. I am your lecturer for operating systems. We have reached a new meeting here, our 8th meeting. We are talking about memory management, and in the first video we are going to discuss about memory partitioning. Let's start. So just a little recap. Let's talk about where were we last time. Last time we were talking about things like deadlock, which is the problem of mutual exclusion, which is a problem of concurrency, which is a problem of process, multiprocessing. Now we are done talking about process. We are now going to talk about where the process is being saved. So where does a process be saved in a computer? The answer is it is saved in the memory. So here we are talking about memory management. And the first thing to talk about memory management is memory partitioning. So as you know, memory partitioning, partition means dividing. Why are we talking about memory dividing? Because when we are talking about memory, we are talking about virtual memory. And when virtual memory is involved, we always talk about two things, which are called, you probably don't know this yet, but it's called paging and fragmentation. And paging and fragmentation are two causes that that merge because a problem, and that problem is caused by memory partitioning. So that is why we are talking about memory partitioning. So there are two types of memory partitioning, two main types that we are going to learn. The first one is fixed memory partitioning, and the second one is dynamic memory partitioning. So let's talk about the first one first, the fixed memory partitioning. So as you can imagine, fixed partitioning is dividing a memory into partitions with a fixed size. Here in the left picture we can see that a memory is divided into partitions with the size of 8 megas, 8 megas, 8 megas, 8 megas, 8 megas. And what is the problem of fixed partitioning? Well, here I'll give illustration. For example, we have two processes. The first one has the size of 5 mega, and the second one has the size of 4 mega. So the first one will go here, and it consumes 5 per 8 of this partition here. And of course, it leaves a gap here. And because 5 plus 4 is 9, so you can't put the 4 mega in the gap here, so you put it in here, which is half of the second part. And so it leaves a gap. And this gap is famously named internal fragmentation, which is a problem because now we have an unused gap. And we will come back to this problem later after we discuss about the second type of partitioning, which is dynamic partitioning. So this is an illustration of dynamic partitioning. As you can imagine, dynamic partitioning doesn't have a fixed size of partition. So, for example, in our example before, we have 5 megas and 4 megas. They can be put side by side, but it doesn't mean that dynamic partitioning doesn't have a problem. This we will discuss in the next video. So that is the end of our first video. We have discussed about fixed partitioning, and in the next video we will discuss more about dynamic partitioning. Thank you for your attention, and meet you in the next video.